Hello everyone, welcome to my YouTube channel. Today we are going to solve the today's daily challenge of LeetCode. Question name is minimum jumps to reach and via prime teleportation. The question says that you are given an integer array nums of length n and you start at index 0 and your goal is to reach index n minus 1. From any index I, you may perform one of the following operation. Adjacent step, jump to index I plus 1 or I minus 1 if the index is within bounds. Prime teleportation, if nums of I is prime p, you may instantly jump to any index j not equal to I such that nums of j modulus p equal to 0. Return the minimum number of jumps required to reach index n minus 1. Okay, so we are provided nums and nums array with length n, and we have to start from first index 0 and we have to reach the last index minus 1. From any index we have to perform both the two steps, like we can move previous or forward next step like I plus 1 or I minus 1 index within the bound, that means within the boundary location like 0 to n minus 1, and we can perform prime teleportation if the number is prime. So we can instantly jump any index I not equal to j and says that the number is divisible at particular index must be divisible by that particular prime number p. Okay, so that was question. So let's take the example. For example 1 2 4 6, we can start our index I equal to 0 and we can move adjacent step to index 1 and add the number. When we got prime number we can move to any index j, so we will teleport to the last index I equal to 3 because the number is already divisible by the prime number 2. So our output is 2, that is the minimum number of steps. Okay, so let's take the second example. We are given 2 3 4 7 9 and here output is 2. let's see how it is. We are starting from I equal to 0 and we will take the next step I equal to 1, then I equal to 1, the number is 3 which is a prime number, so we will teleport it to index 4, that is the last index, and the nums of 4 would be 9, that is divisible by 3. So here also two steps are required. So let's take the third example. Like we are given 4 6 5 8 and we can start from index I equal to 0, then we will move forward I equal to 1, then it is not divisible, it is not a prime number, then we will move to here 5 is a prime number but this doesn't divisible by anyone, so we will move forward to 3. So there are total number of 3 steps we have taken from reaching starting point to ending point there, so the output would be minimum 3. So how we can use our approach would be BFS and prime mapping. Okay, so this is the shortest path problem. So every move cost 1 jump and we need to minimize the number of jumps, so we will use BFS. So what is our key observation? We can go from I minus 1 and I minus I plus 1, or if the nums of I is prime, then we can jump to any index j where nums of j modulus p equal to 0. Okay, so we are going to write the code for the same. So our code would be based on BFS. So we are going to write our BFS code. Let n equal to len of nums. So hope it is visible. It is not, then I am going to zoom it. Now write taking the q for BFS, q equal to dq of creating a tuple 0 comma 0 Okay, so the 0 comma 0 tuple represent 0 is represent index, and another 0 represents jump. So from particular index we have taken 0 jump, and after that we will take one set visited set for keeping track of data. So we have taken set that is initialized with empty list filled with 0, and after that we will use used prime which is initialized with set. Okay, we have taken one another set used prime. Then I will take while loop, while q. What we have to do, every time we have pop left q comma I, the index, and the number of steps. These are two things in our tuple. So we will pop q dot pop left. We will pop the q. After that, what we have to do, we will check the base case like I equal to n minus 1. If we have reached, then we will return steps, how many number of steps are required. So as the question says, we have done it. Then we will go through the loop for ni in the, what we can do, we can make I minus 1 step, and we can make I plus 1 step. For every new step or every new I, we have taken 2 steps, and we will check the boundaries. If ni is less than equal to, ni is greater than equal to 0, and ni is less than n, and ni not in visited. Okay, so I think it is not visible now. Okay, ni is not in visited, then we have to add it to visited array or visited set. Visited dot add ni, and after marking it visited, we will append it on our q dot append. What we have to append, we will append as a tuple. Like first it is ni new index, and we will take our step plus 1. The number of steps will be incremented with 1. Okay, so after that, what we have to do, we will take the value val that is equal to nums of I. Then we will check if is prime val. If number is prime, then we have to do val, and we will check val not in used prime. Okay, if it is not used prime and it is a prime number, then we will, what we have to do, we will check for ni in prime map. Ni in prime map val, we will check if ni not in visited. Okay, if ni not in visited, then we have to again add it into our visited dot add ni, and we have to append it in our q dot append ni. We have to append as a tuple like ni comma step plus 1 steps plus 1. Then what we have to do, we have to make our used prime dot add. We have to add our used prime or update our used prime. So we will add used prime dot add val. We will add our particular value to our used prime, and finally we will, if it is not, then we will return -1. Okay, so for checking prime we have to write the prime function, is prime function. So we are going to write function def is prime, and we are passing parameter x as a number. So we have to check whether the number is prime or not. We will check if x is less than 2, then we will return false. Okay, and for I in range from 2 to is qrt of x plus 1, we will iterate through the square root of the number, and we will check if x modulus I equal to 0, that means any number is divisible with x, then we will return false, the numbers cannot be prime. Otherwise we will return true, number is prime, and we will make a prime map, prime mp. Okay, so we will make it default full dict, default dict, and pass as a list type. Okay, then we have to fill our default full dict, so we will fill it for idx comma val in enumerate nums, and for we will make variable temp equal to val, and d equal to 2, let's, and while d into d is less than equal to temp, then while d into d is less than equal to temp, we will check one second, if temp is divisible by modulus d equal to 0. If temp is divisible by d, then we will add prime map of d. So we will put prime map dot d append idx. Okay, for value, if value is divisible by d, then we will put the index for that value, and we will check another loop, while temp modulus d equal to 0 for every number that is divisible by d. We will update our temp divisible by equal to d. So in this way we can reduce the temp, and we will update or increment the d plus equal to 1 each time. And finally we will check condition, if temp is greater than 1, then we have to append inside the prime map dot prime map of temp dot append idx. Okay, so let's try to run this. There's a runtime error, let's see. So nums is not defined, so we have written num in place of nums. Okay, len of nums. Now try to run this. Okay, so it is accepted now. Now try to submit that. just pending, preparing time environment, running test cases. Okay, it is accepted. So we have solved the question using BFS approach, and we have used BFS plus prime mapping. And let's talk about the time complexity. So the time complexity is big of n square root of max of nums. So in this way we have found prime mapping with BFS. For BFS the complexity is big of n and overall is big of n into max or square root of max of nums. Okay, so thank you for watching, hope you understood this.